Okay, so we're going to go through inverse functions. Now, an inverse function, they've written this like f at x, where we're essentially going to replace f at x with y. Then we're going to invert essentially where our x and y are in this question. So we have y is equal to 3 divided by x minus 4. Well, to get an inverse function, we take our y and our x, and we change their spots. So we're then going to have, no, actually we'll keep it in red. X is equal to 3 over y minus 4, right? And that's a part you know. The next thing we have to do is set this back equal to y. So when setting this equal to y, what I want you to notice, okay, is we have a fraction on one side. And usually the easiest way to deal with anything is kind of get rid of our fractions. So think of this. This is a number is equal to a fraction, or we can make x a fraction also. How would x become a fraction if it was what?
Over 1.
Yeah. So now we have equivalent fractions. How do we get rid of the bottoms of fractions when they're equivalent? There's a type of multiplication they use.
How do you get rid of it?
Yeah, how can we make everything so it's kind of, there's no more division essentially involved?
Multiply.
Yeah, multiply, and it's called something called cross multiply. Do you remember this at all?
Yeah.
Yeah, from way back when we were younger. So if we were to cross multiply, let's just kind of go back. Go back up. If we cross multiply, we'd end up with x times y minus 4 is equal to 3 times 1, which is 3. Okay, so we essentially went from here to here. Okay, there shouldn't be two equal signs there, but that's what we did. We're trying to get what by itself?
We're trying to get y.
Trying to get y by itself. Okay, so how can I get the x out of this one side here?
Divide.
Divide both sides by x. Okay, and then what are we going to have?
Y minus 4 equals 3 over x.
Yep. 3 over x. Okay. And then what are we going to have?
Just add the 4 on the other side.
So we're going to have y equals
3 plus over x plus 4.
Plus 4, that's right. Do you know what type of function this is?
Linear.
Not linear. Linear is when x is to the power of 1. Technically, what's this to the power of, this x? If I were to make it all even. It's technically, you could say, if I wanted to make this on the same level as 3, it'd be x to the power of negative 1. So I'm going to break this function apart just a little for you to remind you of something. What does that look like now?
Not linear.
Not linear. What type of function?
Is it it? No. It's a
While you do that, I'm going to set up a graph.
yeah. Oh, it's the two curved lines.
What are they called? Should be a name for it.
I forget.
Well, linear, quadratic, absolute, root, exponential, starts with R. Reciprocal. Do you remember that at all?
Yeah.
Okay, so let's say we have a reciprocal function. The reciprocal function, it took us a little bit to get there, is y is equal to 1 over x. Now that function is essentially drawn like this, where there's a horizontal and vertical asymptote, where essentially they don't touch those two lines. So it goes like this, and it goes like this. Okay, so the domain and range is going to be a little tougher for this one. This here is like an a value, so it's saying it's been vertically stretched by a factor of 3. Okay, so we're going to get stretched by a factor of 3, but our domain and range, that won't really affect it. Okay, all that's going to do is going to make it look, I guess we can use another color here. It's kind of going to look like it actually takes off even faster, and then when it's a lower number, vertical stretch is going to pull it up a little, I guess. So yeah, it's kind of going to look like this in terms of the domain and range. It's going to be a little higher, but it's still, and a little lower here, you could say. Going to look something like that in terms of stretch that's been pulled upwards, but the asymptotes are still the exact same. Okay, they're just going to be farther apart. This is what's important. Positive 4. What does that mean for this function? Underline in green.
It means that it's going to move up 4.
Yeah, it's going to move up 4. So this x-axis, where y was equal to 0, where that was one of the asymptotes, that moves up 4 units to 4 now. Okay, so now at 4, I have my horizontal asymptote, and essentially the same function still, just with a horizontal asymptote there. Vertical asymptote, oops, go a little lower, and here. Vertical asymptote is still the y-axis. So when we go to do our domain, you could say that the domain of this function is x is every real number such that x cannot equal, well, the only x value it can equal is 0. So it cannot equal 0. And the range for this one, y is every real number such that y can't equal what due to this? It's not 0 anymore. It used to be 0. 4. That's right. So because we have a reciprocal function like that, and it got shifted up 4 units, the horizontal asymptote got shifted up 4 units. So we can't, y is every number except 4, and x is every number except 0.